Hi, hello, namaste, friends. Welcome back to Raman tutorial. Dear friends, today class we are going to learn about the topic gravitation. So, gravity. Which scientist found out the gravity? That scientist name is Isaac Newton. So, another topic that related to that one is gravitation. Gravitation is nothing but it is a force of attraction between the two objects. Gravitation is force of attraction between the two objects. It is not only in Earth. After that, Newton studied that it is a universal phenomenon. Every object in the universe attract other object with the force. That force is called as gravitation. If Earth attracts the object, that is called gravity. So the Newton, when he sat in a garden, he saw the apple fell on his head. So he found out the gravity. After that, it did research that, and he told that gravity is not only present on the earth, it is present everywhere in the universe. So in universe, every object attracted each other. That force is called as gravitational force. So like that, gravitation in compared to the four forces, this is considered as very weak force. So other in a nature, there are four forces are there. What are the name of that forces? The name is gravitational force, electromagnetic force. The name are gravitational force, electromagnetic force, strong nuclear force, and other is weak nuclear force. So in the nature, dear students, dear friends, there are four forces are there. In four forces, gravitation is the weak force, which is the strongest force in the nature. Very good. It is strong nuclear force. And among these four forces, gravitation is a weak force. These are the nuclear force present inside the nucleus. This is the microorganism. It is short ranges forces. Strong nuclear force and weak nuclear force, they are short ranges forces, and gravitational force is between the attraction between the two objects in the nature. Electromagnetic force is force between the charge particle. So in these four forces, nuclear force is strong force, gravitational force is a weak force, force between the charges, and the weak nuclear force is during the decay of alpha and beta gamma, that force is there, that force is called nuclear force. Now, LGBT importance in interaction of elementary particles. Gravity is the primary importance in the interaction of object, gravity that hold the universe together. Suppose imagine, my friends, if gravity is not there on the earth, is it possible for us to stay here? Is it possible for making the house and other things? It is not, it will be not possible. The gravity is there that holding us. So now, after the research, the Isaac Newton in 1827, he found out the universal law. That law is called as Newton law of gravitation. Suppose students, if we take the two objects, one object mass is m1, another mass is m2. One mass is m1, another mass is m2. The distance between them is r. This is the one mass. This is the one mass. Two objects are there. Distance between them is r. So Newton find out the universal law of gravitation, and the Newton explained that gravitation is not only a earth phenomena, it is a universal phenomena. Each and every object in the universe, attraction will be there. So the universal law of gravitation tell about the three factors. Tell about the force, and that force depend upon the mass, that force depend upon the distance. Suppose, my dear friends, if you take the two magnets, if the magnets are small, attraction is small. If the magnet are bigger, attraction are will be more. If the distance is more, if the two magnet we are keeping far away, what will happen? The force will become the less. If you bring the two magnet, two poles near, the force will be more. So here in Newton's law of gravitation, Newton explained that force of attraction between the two objects M1 and M2 directly depend upon the product of masses and inversely proportional to the square of the distance between them. So gravitational force is a repulsive force or attractive force, electromagnetic force, force between the charged particle that is attractive and repulsive. But the force here of gravitation is only attractive, there will be no repulsion. Attractive between the two masses M1 and M2 separated by a distance, whether it considered as R, whether it is considered as D. So gravitational force acting between the 2 points is directly proportional to product of mass and inversely proportional to the square of the distance between them. What does it mean? The meaning of this is if the two masses are increases, what happened to the force? Decrease or increase? Absolutely right. If the two masses is increases, force of attraction between them increases. If the two objects keep very far away, as the distance increases, force will be decreases. That's why we are telling that force between the two objects is directly proportional to product of mass, inversely proportional to square of the distance between them. Hope, my dear friends, you understand this. Thank you very much, dear friends, to join the Raman tutorial. We are ready to help you any walk of life, any kind of the problem. You can directly ask the question. Wish you all the best for your exams. Hope you will get the good rank and you will got selected for the government job. So here, here we are using the capital G. Small g students is called as acceleration due to gravity. Small g is called as acceleration due to gravity. Small g is called acceleration due to gravity. This is the capital G, my friends. That is called as universal gravitational constant. That value is 6.67 into 10 to the power of minus 11. That is Newton meter square per kg square. Is the same throughout the universe. Universal gravitational constant. Why it is called as universal gravitational constant? This value is constant for whole universe. This Newton's law of gravitation. Newton's law of gravitation is called as universal. Why we are calling it universal? My dear friends, we are calling it universal because this law is applicable each and every part of universe. So, dear students, Assalamu alaikum. जी, अभी दवाखाने में हूँ, अभी डॉक्टर का वेट कर रहे हैं, ग्लूकोज लगे थे अभी। हाँ, अभी जब से अभी तक रूम में आप इंजेक्शन दे के भेज दो मेरे घंटे के बाद। अब थोड़ा आराम, हाँ बहुत ये हो रहा था, मतलब छाती में रहते मतलब सर्दी को सांस लेने प्रॉब्लम आ फीवर की बहुत है। जी जी, इंजेक्शन देते हैं तो उसके बाद होना है। भेज तो बोल रहे हैं तो सुबह में जाना है। जी सो डियर फ्रेंड्स, this is the gravitational constant. Its SI unit is Newton meter square per kg square, and the G is independent of the nature and size of the body. This gravitational constant not depend upon the medium, not depend upon the size of the bodies. Now, the dimensional formula of this one is here is mass square and distance square. So distance, so gravitational constant, force, distance square, time. So that is the formula for gravitational constant. That is mass, length, and time. So now move ahead. Importance of universal law of gravitation. So dear friends, what is the importance of gravitation? Gravitation is a central as well as conservative force. This depend upon the 2 points. It not depend upon the path followed. So it is called as conservative force. It is the weakest force in the nature. It is 10 to the power of 36 times smaller than the electrostatic force. If you take a foam and rub with the hair and it will attracted by the paper, that is electrostatic force. This force is 10 to the power of 36 times lesser than the electrostatic force and 10 to the power of 18 times smaller than the nuclear force. So that is, it is a very, very weak force. Now, law of gravitation is applicable for all bodies irrespective of size, shape, and position. This universal law of gravitation is applicable to small and big. It not depend upon the shape. The gravitational force acting between the sun and planet provide the force. That's why the planets revolve around the sun. Imagine the students thousands year, many years around the sun, 8 planet is moving. Why they are not leaving the sun? This is called as geocentric theory or heliocentric theory. It is heliocentric theory because of the gravitational force. The planets are revolve around the sun. Now, gravitational pull of the earth is called as gravity. We are walking on an earth, our building, our house, or all the plants, or all the systematic balance is there because of the gravity. This was explained and discovered by the Isaac Newton when he sat in a garden, apple fell on his head. So he thinking that why it is not going anywhere, why it is coming to the earth, because there is earth is a big magnet. It attracts the object. This is not on. This is not repulsive force. It is only attractive force. So now about Newton third law of motion. What is Newton third law of motion? Every action there is equal and opposite reaction. Hold goods for the force of gravitation. It means gravitation between the two body is action and reaction. Gravitation between the two body. This body attract this body attract this body. So each and for every action there is equal and opposite reaction. You see the rocket, the gases are coming down and the rocket will move upward. So gases coming down is an action, rocket move up is a reaction. So that is a Newton third law. If you take a balloon, fill up with the gas, it will leave it. That is also a Newton third law. Every action there is equal and opposite reaction. So the Newton third law hold goods for the gravitation. Gravitation is force of attraction between the two objects present in the universe. So now the 3 points important regarding the gravitational force. Unlike the electrostatic force, it is independent of medium between the particle. This gravitational force don't depend upon the medium. It is independent of the medium. It is a conservative in a nature. The force depend upon the distance between the 2 points. It is not depend upon the path followed. The third point is the force between the point masses. However, for external points of a spherical bodies, the whole mass can be assumed to be concentrated at the center of a mass. Suppose student, this is the mobile. If I'm holding this in my point, this point whole mass is concentrated. This point is called as center of mass. Now, dear students, Newton find out the gravity. Newton find out the universal law of gravitation. Universal law of gravitation depend upon the three factors. Force is directly proportional to product of mass, inversely proportional to the distance. That mean is there. Masses are increases, force is increases. Distance is less, force is more. Distance is more, force is less. So now come to the point. Newton's law of gravitation hold good for object lying on every very large distance. It is a long range force. Nuclear force is a short range force. Gravitational force is a long range force. And also a very short distance. It fails when the distance between the object is less than very small microparticles. This laws is fail if the distance between is less than 10 to the power of minus 9 nanometer. Now about the acceleration due to gravity. Suppose students, I am throwing the object. It is coming down. So it is acceleration. What do you mean by acceleration? Acceleration is rate of change of velocity. Acceleration is rate of change of velocity when any object throw up, it coming down because of gravity and they are gaining the acceleration because of the gravity. Acceleration due to gravity is representing by small g. This value is equal to 9.8. This value is 9.8. So uniform acceleration produced in free falling body. Somebody is falling from the helicopter, that somebody is coming down in a space, something is coming down in a space, that is called as free fall. If someone went to the 10th floor building and throw the some weight, that coming down, that is called free fall. So they gain the acceleration, that is called as acceleration due to gravity. It is denoted by small g. This is the object moving in not horizontal, the object is moving in vertical direction. And the assignment of acceleration to gravity is meter upon second square. Whether it is a vector quantity or scalar quantity, it is a vector quantity. But what do you mean by vector quantity? The quantity have magnitude and direction. Its direction is toward the center of Earth. The value of G is the value of G is independent of mass of an object. The value of G is independent of mass of the object. So the small g is equal to capital G m by r square. So acceleration due to gravity is not depend upon the mass of an object. The value of g change from place to place. If someone go to the mountain and hill areas, what happened to the acceleration due to gravity? That value will be less. The value change. The value on a moon is become 1.16 of that on Earth, and on a sun is about 27 times than that of the Earth. That on the sun it is maximum more, 27 times of that of Earth is greater. But as far as this g value is concerned, this acceleration due to gravity is concerned on the moon, it is 1 by 6 times. Suppose my weight is 60 on the Earth, what will be my weight on moon? 60 divided by 6, it become 10. So if my weight is here 60, what will be my weight on sun? That is 27 multiplied. Now, see here, the acceleration due to gravity is minimum on Mercury because the smallest planet, it has a very less gravity. The relation between small g and the relation between capital G. Small g is called as acceleration due to gravity. Capital G is called as gravitational constant. So the small g is equal to capital G m divided by r square. This m is mass of the earth. It is not a mass of object. Acceleration due to gravity is independent of mass of an object. If you throw heavy and light object, all will same. But here in air on earth, air resistance will be there. Same activities will do in a space. On the moon, heavy and light object. The plastic ball and the laser ball both will come with the same speed. Acceleration due to gravity is not at all depend upon the mass of a object. R is the radius of a earth, that is 6.38 into 10 to the power of 6 meter. Now, acceleration due to gravity at a height, that is the formula is given here. Now, the factor affecting the acceleration due to gravity, that is capital G or small g. My dear friends, it is small g. Now, you know very well what is the shape of the earth. Earlier, they are thinking about flat. The next, they told that it is a circle. Now it is a oval shape. The shape of the earth is oval, that is elliptical X shape. Acceleration due to gravity G. 1 by r square is an elliptical in shape and its diameter at pole is approximately 42 kilometer less than the diameter at equator. This is the equatorial line and these are the pole. Where will be the acceleration due to gravity is maximum. The diameter at pole is 42 kilometer less than the diameter at equator. And the acceleration due to gravity value is minimum at equator, maximum at pole. Hope you understand this, my friends. Let's move ahead. Discuss about the rotation of Earth about its own axis. Because of its rotation, what is forming? Day and night. When the Earth is rotated because of this, day and night are forming. And this is called as angular velocity omega. Angular velocity of rotation of Earth is about its own axis, the acceleration due to gravity, and the latitude height given by. This is the formula: acceleration due to gravity minus radius of the Earth, angular velocity, cos angle, that is the latitude. The latitude at pole is 90, g equal to d, g, therefore there is no effect of rotation of the Earth on its axis at a pole. This is the points. Now, my dear friends, see here the value of G is where the G is maximum, where the G value is minimum. The value of G is maximum at pole. The value of G is minimum at equator. So now, dear friends, move ahead. Let's discuss about the what will be the effect for to the acceleration due to gravity when height will be increase and decrease. The value g at height h from the earth's surface, that is equal to g1 upon g1 plus h into by r into square. Therefore, g value decreases with altitude. Sea level, that value is different. If we go to the higher altitude to the mountain or Mount Everest, if we go far away from the earth, the G value will increase or decrease. This value is go on decrease. Now about the depth. Instead of going up, the G value is decreased. If someone is go deep inside the ocean inside, again the depth from the earth's surface, the G value decrease with the depth. The value becomes zero at the center of the earth. As from the earth, if we are going up, G value decreases. Ground level ocean, if we go in inside the ocean, again in a depth, G value is decreases. At the center of the earth, the whole mass is zero. So G value also become zero. Now let's discuss about gravitational field. Gravitational field is nothing but, suppose my hand is going this much direction. What is the space the gravity is attracted? If we are a student of Karnataka state, the state has some boundary. Other neighbor of Maharashtra and the Tamil, other state are there that have the boundary. If anyone go to the ground, plain ground, the ground has some boundaries there. So gravitational field is nothing but it is an area, it is a space surrounding any body which is gravitational pull can be experienced the other body, that is called as gravitational field. Intensity of gravitational field can be defined as gravitational force acting per unit mass at Earth. Any point in a gravitational field is called intensity of gravitational field. Gravitational force acting per unit mass is called as intensity of gravitational field. That is denoted by Eg or I. I is equal to force, gravitational force and a mass. Now intensity of gravitational field at a distance r from the body and the mass is given by I is equal to gravitational constant, mass of a body, distance, then. So intensity of gravitational field is a vector quantity. They have both magnitude and direction, and it's towards the center of gravity. Now intensity of gravitational, it is upon intensity of gravitational fields, force upon the mass. Force upon the mass, force is the Newton, and that meter is a distance. So the dimensional formula of intensity of gravitational fields, force upon mass, that is dimensional formula is length upon t minus 2. So next, meter is the length. Next is about gravitational potential. That is this we are learning now about the, if we are eating the food, the store energy is called as potential energy. If we purchase the petrol from a petrol pump, that have the energy, that is called potential energy. All the fruits, all the food we are using, that is the potential energy. If we use the catapult, stretch to the backward, due to the stretch, they gain the energy, that is called potential energy. Energy due to its position on the ground. So that is called as gravitational potential energy. The meaning of gravitational potential energy is equal to work done in bringing a charged body from infinity to that point. Gravitational potential energy is defined as amount of work done to bringing a charge from infinity to that point. This is our universal gravitational potential energy. The negative sign shows that gravitational potential energy decreases with increase the distance. Gravitational potential energy represented by U, that is equal to minus capital G and M divided by R square. Gravity divided by R. This is gravitational constant, mass of the earth, mass of the body, distance between them. So the gravitational potential energy at height from the surface of the earth can be written as, this is our earth, this is the radius, this is the distance we are increasing. So at one point, that is delta x, from the center of the earth to the height that is the x. So my dear friends, this is the gravitational potential energy at the height from the surface. Gm upon into m divided by r plus h mgr upon 1 plus hr. My dear friends, this is the gravitational potential energy is equal to amount of work done to bring a object from infinity to the point that is represented by u. The potential gravitational potential energy is decreased with increase in the time. So the formula of weight is that is Newton gravitational mass is equal to weight upon gravitation acceleration due to gravity. Now on the earth we have the different vehicles that moving on the earth. When the people are dream about go to the space, first they discover the rocket. The top of the rocket that we are telling the payload. The top we are keeping the device that is called as satellites. Students have seen the satellites. Why we are using the satellites? Moon is a natural satellite. NASA and ISRO, they have sent so many satellites into the space. INSAT, Indian National Satellite, and geostationary satellite. So many satellites they have sent into the space. We are sending the satellite into the space. That device that sends the satellite that is called as rocket. The satellites are two types, natural and artificial. Moon is a natural. Other satellite that man-made they are sending to the space that is called as natural satellite. Celestial object, heavenly object revolve around the planet. The celestial object revolve around the sun is called as planet. The celestial object, the heavenly object revolve around the planet is called satellites. The natural satellites are heavenly objects which are not man-made. Artificial satellites are heavenly objects. They are made by man-made and they launched for some purpose. So what is the purpose of using the satellites? It is used for communication. It is used for weather forecast. It is used for searching the any minerals and other things on the surface of other planet. Mercury. Other planet is about the Mars. So that is mission Mangal and Chandrayaan. Now, time period of a satellite, that formula we are writing. So now, the near the Earth surface time period of a satellite, that 2 pi r cube by gm. So next is about the artificial satellite or man-made satellite. The man-made satellite, my dear friends, are two types. Geostationary satellite or other is polar satellite. The polar satellite move in the direction north to south pole. Geostationary satellites revolve in an equatorial line. Geo means earth. Stationary means rest. So it has the period of rotation as equal to the period of rotation of the earth, 24 hours. If somebody see that satellites, it look in a rest position because of period of rotation of earth and revolution is equal. Period of rotation of earth is equal to revolution of the satellites. It appear to be rest, that is called as parking satellite or geostationary satellites. A satellite which appear to be fixed position at different height observed on the earth, that is called as geostationary satellite, move in equatorial line, and the satellites move on a pole, that is called polar satellite. Height of the Earth from the surface is 36,000. The radius of orbit is 42 4,400 times for 24 hours. Orbital velocity is 3.1 kilometer per second. Angular velocity 2 pi by 4. That is this. The satellite revolve around the Earth in a equatorial orbit. That is from east to west equatorial line. Geostationary satellite revolve around the Earth in a equatorial orbit. Angular velocity of satellite is same in magnitude and direction. Angular velocity of Earth is on axis. Now, what is the benefit of satellites? It is for global communication, internet. Now we cannot forget the benefit of satellites. So many purpose we are using the satellite. Communication purpose. INSAT 2B, INSAT 2C are geostationary satellite revolve around the Earth in a equatorial orbit. Other satellite is it is not geostationary, it is polar satellites. That satellite which revolve in a polar orbit. The polar orbit is about whose angle of inclination with equatorial plane is 90 degrees. This polar orbit equatorial, that angle is 90 degrees. The height from the Earth 880 kilometer time 84 minutes. Orbital velocity 8 kilometer per second. Angular velocity is this value. So the satellite revolve around the Earth in polar orbit. There are the two type of satellites that revolve in an equatorial line. There is a satellite that is revolve in a polar orbit. These satellites are used in weather reporting, study about the atmosphere, mapping, and all the things, many purposes. Nowadays, it is very, very useful for us. We are using it for many purposes. PSLV, Polar Satellite Launching Vehicle. Polar Satellites Launching Vehicle. Series of the satellites are revolve in. These are the example of polar satellite in a pole. Inside series of the satellite, these are the geostationary satellite. They are moving in a equatorial line, east to west. But as far as polar satellite is concerned, they are moving in up and down, north to south, south to north pole. Example of polar satellite is PSLV. Example of geostationary satellite is INSAT series. East to west, this rotation revolution is called as geostationary satellite. North to south revolution is called as rotation. Revolution is called as polar satellite. An example of polar satellite is polar satellite launching vehicle. When the satellite sent into the orbit, they are moving with the circle in a circle. They are moving. So the velocity of a satellite in a circular path, that is called as orbital velocity. Orbital velocity of a satellite is minimum velocity required to satellite to put into the orbit around the Earth. The velocity which the satellite revolve around the Earth, that is called as orbital velocity, that is written as V naught gm by r. So that is the formula. My dear friends, m is the mass of the planet, r is the radius of the planet, height of the satellites. If the satellite is revolving near the Earth's surface, this formula we have to use. Now orbital velocity can be written as square root of acceleration due to gravity and radius of the Earth. If the satellite revolving near the Earth's surface, My dear friends, the speed of a satellite in this orbit is required orbital velocity. Now, let's discuss about energy of a satellite in a orbit. The total energy, the mechanical energy, total energy is called sum of kinetic energy and potential energy. That formula Gm by small m by 2r. Now about the binding energy. So there is a nucleus. They have the proton and neutron. The force holds the proton neutron in the nucleus, that is called as binding energy, or the energy required to remove a satellite from the orbit of the earth to infinity. This is also binding energy for the nucleons. The binding energy is also for the satellites because they are revolving around the earth. The energy required to remove the satellite from the earth orbit. If we want to remove the satellite from the orbit, we have to do the work, we have to supply the energy. Energy required to remove a satellite from its orbit around the earth to infinity is called binding energy of the satellites. Binding energy of satellite of a mass is given by BE means binding energy, gravitational constant, mass of the earth, mass of the object divided upon. That is R is called as, small r is called as, so now dear friends, let's discuss about escape velocity. So now see here, if I throw this, where it will come? It's come down. If we send the rocket in a space, it required minimum velocity, otherwise the rocket will come back to the earth. Escape to remove to go out from the earth atmosphere. There need a minimum velocity. If the velocity is very less, it is impossible for satellite or rocket to launch the satellite into the space. The less speed is there, it will come back to the earth. Escape velocity means the minimum velocity with which a body projected vertically upward to escape from the earth gravity. So it is just cross the earth gravitational field and never return. It will move in a circular orbit. So that escape velocity is called as, this is called escape velocity that depend upon acceleration due to gravity and radius. Escape velocity doesn't depend upon mass and shape of a body. In examination, teachers examination, they're asking whether what is the formula of orbital velocity or escape velocity. What is the relation between small g and capital G? As the height, what is how the acceleration due to gravity depend? And they are asking the question is why the gravitational constant is called universal. What is the value of small g and capital G? Acceleration due to gravity, gravitational constant. If we go to the moon, the gravity will become more or less, gravity become less. Escape velocity doesn't depend upon mass, shape and size of the object as well as direction of projection. The minimum velocity required for satellites to escape from the earth is 11.2 kilometer per second. If less than speed is there, it will again fall down to the earth. Now, some important escape velocity. Mercury is 4.28 km per second, Earth is 11.2, Jupiter is 60 km per second, Sun is 618 km per second, the neutron star 2 into 10 to the power of 5 km per second. There is a relation between VE means escape velocity and VO means orbital velocity. Escape velocity is equal to square root of 2 into orbital velocity. This is the formula they are asking about which is the right relation between escape velocity and orbital velocity. This is the formula. If the velocity of projection is equal to the escape velocity, the satellite will escape away from a parabolic path. The velocity of projection of a satellite is greater than the escape velocity, then the satellite escape from the hyperbolic path. The velocity of projection of satellite is greater than the escape velocity. Now one condition is there called as weightlessness. Somebody is under the free fall from the space that is coming down, that is called as weightlessness. The object freely fall is observe, consider, act as a weightlessness, zero weight. In a situation in which weight become a zero, during the free fall under gravity, inside the spacecraft or satellite, you are feeling weightlessness. At the center of the earth, inside the satellite and the spacecraft, you are feeling weightlessness. Somebody is falling from the earth under the gravity, that is also we are feeling weightlessness. And when somebody is in a lift, freely falling lift, that also explain the weightlessness. Now let's move ahead. There are the two, three laws are there about the planet. Kepler's law of planetary motion. So my dear friends, law of orbit, law of area, law of period. There are there are three Kepler's law of planetary motion. Who is revolving around the sun? Planets. They have the planetary motion. They are not escaping from the sun because they are holding by gravitational force. All the planets revolve around the sun. The first law is telling about the orbit, the path in which satellites are moving. So every planet revolves around the sun in an elliptical orbit and sun is at the center. Orbit means the path surrounding the planet. Every planet revolves around the sun. Every planet revolves around the sun in a elliptical orbit in an oval shape. Sun is at the center. All the planets they are revolving around the sun. Now about the period law of orbit is over. Now about the law of area. The radius vector drawn from the sun to the planets sweep out an equal area and equal interval of time. That aerial velocity of the planets around the sun is constant. So now the third law of Kepler's, that is law of period, that is tell about the relation between time and elliptical orbit. The square of the time period of revolution of a planet around the sun is directly proportional to the cube major semicircle of elliptical orbit. This is called as law of period. Three laws we all learn. One is about the law of area, law of orbit, law of area. The third one is law of period. Now discuss about the important points. A missile launched with a velocity less than the escape velocity, some of the kinetic and potential energy is negative because it is going up against the gravity. The bomb exploded on the moon. You cannot listen the sound on the earth because sound need a medium to travel. A bottle filled with the water at 30 and filled with the cork is then to the moon. If the cork is open at the surface of the moon, then water will boil. For satellite orbiting the surface, orbital velocity, the Earth is moving around the Sun is 8 km per second. Time period is about 84 minutes. Angular speed 2 pi divided by 18. Initial mass and gravitational mass. Initial mass is force by area inertial. Gravitational mass is weight upon acceleration to gravity. Next is about This one, my dear friends, in today class, these points I have completed. So once again, I am telling you about, please listen. So my dear friends and the teachers, thank you for joining the Raman tutorial. Hope that your future will be bright. You will be in the next level after a few days, a few months. Gravitation, gravity is force. Once again, I'm just quick revising. I'm doing this. Gravity is object coming towards the earth. Gravitation is force of attraction between the two objects. In the universe, there are the four forces in the nature: gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. Among that weak force is gravitational force. Strongest force is nuclear force. That is short range force. Gravitational is a long range force. Electromagnetic force flows between the charge. Newton, after finding the gravity, he observed the celestial object. He come to the conclusion that he found out the laws of motion and he found out the Newton law of gravitation. It is called as universal, applicable to universe. So the force of attraction between the object is directly proportional to the mass and inversely proportional to the square of distance between them. The capital G is gravitational constant, that is 6.67 into 10 to the power minus 11. And the some properties of the gravitational force. It is a conservative force, weakest force, and it is applicable for all the bodies. Gravitational force between the sun and planet is provide the gravitational centripetal force. The gravitational pull of Earth is called as gravitational pull of Earth is called as gravity, Earth and object. The third law, action and reaction must be equal and opposite. Now, 3 points important regarding the gravitational fields. Unlike electrostatic fields, ele- electrostatic force, the gravitational force is independent of the medium. It is a conservative force, depend upon the 2 points, not depend upon the path. The Newton law of gravitation holds good for all objects in the universe. And this law is fail when the distance between them is less than nanometer in microparticles. Now about the acceleration due to gravity. Something is falling from the height to the down. The acceleration gain are produced in a freely falling body due to the gravitational pull. What is about just is here? They are telling about what is gravity. Gravitational pull of an earth. Now about the g value, acceleration due to gravity represented by g, that SI unit is meter upon second square, and it is a vector quantity. And the acceleration due to gravity is independent of mass of an object, heavy or light. This value is 9.8 meter upon per second square. And the relation between small g and capital G. The small g is acceleration due to gravity. Capital G is gravitational constant. The acceleration due to gravity is minimum on the surface of a planet, that is Mercury. Now, the relation between small g and capital G, it is free from the, not independent of the mass of an object. Factor affecting the acceleration due to gravity, shape of the earth, rotation of the earth about its own axis, effect of height. The value of G is minimum at equator, it maximum at pole. So G is decreased with the depth, G is decreased with the height. Gravitational field is the area surrounding the object in which gravitational pull can be experienced. Intensity of gravitational field. The gravitational force acting per unit mass at Earth any point is called gravitational field. That is represented by IgM by R square. That is the dimensional formula, and gravitational mass is defined by Newton's law of gravitation. Gravitational potential. means amount of work done per unit mass in bringing the light body from infinity to another point. Next definition is gravitational potential energy. The gravitational potential energy at any point is equal to work done in bringing it from infinity to that point. That is gravitational potential energy represented by U. That is Gm by m by G is gravitational constant, mass of the earth, mass of the object, distance between them. So that is the formula. Satellite is a celestial object, or it is natural revolve around the sun, and artificial, that is heavenly object, revolve around the planet. That is called as satellite, natural satellite object which are not man-made. So my dear friends, there are the two type of satellites: geostationary satellite, polar satellite. Geostationary satellite revolve about a fixed position at particular height. So the polar satellite revolve in a pole. Example of geosatellite is INSAT, and the polar satellite is PSLV series. Orbital velocity of a satellite is minimum velocity required satellite into a given orbit. Orbital velocity, the minimum velocity required for a satellite in a orbit to revolve. So the orbital velocity is 7.9 kilometer per hour. Now about the energy of the satellite. Total energy of satellite is sum of kinetic and potential energy. Binding energy. The electron are the satellites are holding with the around the satellites are revolve around the planet. So energy required to remove the satellite from the orbit, that is called binding energy. There is a centripetal force is there that pulling the satellites around the planet. To remove the satellite from that planet from the orbit, we have to supply some amount of energy. That is called as binding energy. So if we are launching the rocket at the top payload, there is a satellites. If we want to launch the satellites into the space, they require minimum escape velocity. Otherwise, they will come back to the Earth. Elon Musk have planned that after a few years, the people are used to live on Mars. So we have the India have the Chandrayaan and Mission Mangal. So that formula of escape velocity is 2g into r. The relation between orbital and escape velocity is orbital velocity is equal to square root 2 into escape velocity is equal to root 2 into orbital velocity. Weightlessness. Somebody is falling from a high from the rock, from the helicopter. Some person is coming down under the gravity. That condition is called as weightlessness. In this situation in which weight becomes the zero, freely falling under the gravity inside the space and satellites, we are feeling in a satellite inside a spacecraft aeroplane, we are feeling weightlessness at the center of Earth. Now Kepler's explain about the three laws. Law of orbit. Every planet revolves around the sun in a elliptical orbit. The second law is related to the time. The square of the time period of revolution of a planet around the sun is directly proportional to the cube of semi-major axis of an elliptical orbit. Important points. The missile is launched with the velocity less than the escape velocity. Sum of kinetic and potential energy is negative. Orbital velocity or speed of a Jupiter is less than the orbital of Earth. A bomb exploded on the moon, we are not able to listen the sound because sound is a mechanical wave. A bottle filled up with the water at 20 degrees Celsius, keep the cork taken to the moon. If the cork is open at the surface of the moon, then water will boil. Orbital velocity, the velocity which The planets revolve around the sun. That velocity is 8 kilometer per second. Escape velocity is 11.2 kilometer per second. Now, internal mass and gravitation, inertial mass is equal to force by acceleration. There are the each and equal magnitude gravitation of a body. In the presence of other body, initial mass, body remain the unaffected. So, my dear friends, here we are going to conclude the topic gravitation. Hope, my dear friends, you will do well in examination. Your result will be more than cut-off percentage. Or that English medium student wish you all the best for the high school teacher's job. We are eager to ready to help you. Thank you for joining using the Raman tutorial. We are ready to help you. Any kind of the doubt, any kind of the problem, my dear friends, you can ask and we are ready to help you. So hope all of you are doing well. All of you are doing well. So these are the some important points regarding the gravitation. We have discussed about the universal law of gravitation. We have discussed about the weightlessness. We have discussed about the orbital and escape velocity. We have discussed about the universal law of gravitation. And we have discussed about the acceleration due to gravity. Hope, my dear friends, you understand this concept. Please prepare well for. Thank you for joining the Raman tutorial for GK. So, mental ability or English or grammar or any kind of the things, general knowledge, current affairs, please prepare well and try to do well. Be cool, be calm during the examination. If you knew all the things, because of that only stress and pressure, we cannot take a decision fast. So be cool, be calm, be confident. Yes, sure you will be a come up as a winner. You will get the selection card, good rank, and you will get selected. So thank you very much for using the Raman tutorial. This is Tajuddin going to conclude the class as a MSc lecturer, MSc physics lecturer. So we will we will meet to the next class for the next topic. Thank you one and all. Wish you all the best for the exams. Thank you, my dear.